Well, you don't need me to tell you that we spent the last week or so dealing with polynomial equations. Definitely a special type of equation because there's so many ways to solve them. Now what we're going to do, though, is continue this chapter by looking at other unique equations that each have their own special solving strategies. Now, each equation that we look at is going to have an exit ticket. So there'll be exit tickets after like every lesson. Please be on the lookout for that, starting with today's lesson. So what do I have for you here? It looks like a nice little equation. 5 plus the square root of x minus 4 equals 2. But I dare you to solve it. Dare you to solve this. Now, in all seriousness, if we were in class, you would solve this. Don't just keep watching the video or waiting for the teacher. You need to pause the video and solve this equation. But you say, I'm scared. You acting like there's something that's going to happen. Well, maybe there's something that's going to happen. That's probably a little bit why I want you to just try to solve it. So pause the video, subtract 5 from both sides, and get her solved. Go. So as I mentioned, you can and should be subtracting 5 from both sides. That's good algebra. What you're really doing is you're getting the square root isolated. Now, once the square root's isolated, you're ready to square both sides. Yeah, square both sides. That's going to cancel the square root and leaves you with just x minus 4. Now, on a good day, negative 3 squared is 9. So, x equals 13? No. X does not equal 13. What? That's the algebra that I did. Why is that not right? You told me something was going to be wrong. Well, let's check one of these things. Let's check 13 back in the original equation. Now, when you check something, you can't work on both sides because you don't know if both sides are equal. So we just kind of work on one side. And I get to 5 plus the square root of 9 equals 2. Now, the square root of 9, it's 3. And 5 plus 3, that doesn't equal 2. Oh my gosh, it doesn't check. But wait, what's that you say? It should be plus or minus? Oh, if it's minus, then it does check? Well, here's the thing. It shouldn't be plus or minus. It's this little sort of nuance in math where you only get a plus or minus if you put the square root in the problem. But you see, I put the square root in the problem. I gave it to you as 5 plus the square root. I didn't give it to you as 5 plus or minus. So we have to be careful not to say that just because there's a square root, there's always a plus or minus. Again, if you take the square root of both sides, then by algebra, we should have a plus or minus. But since I gave you the problem, the way I gave it to you is the way I gave it to you, a plus sign. So it's just 5 plus 3, and sorry, that does not equal 2. Now, what's happening here? Well, what's happening is we have what's called radical equations. And radical equations, yes, they will have radical signs like square roots, but first off, they may produce an extraneous solution. We're just going to have to get over it because that's what happened in this problem. 13, actually forgot to say, 13 was not the solution. There was no solution. It produced an extraneous solution. Okay, now, not every problem will that be the case, but it's definitely something to be on the lookout for. When you're solving a radical equation, use good algebra. Isolate the radical. Just like we did in this problem, we moved 5. What did we do? We subtracted 5. Yeah, you want to always isolate the heart of the problem. In this case, the radical is the heart of the problem. Let's try a couple other radical equations. This one says that negative 27 is equal to 3 times the cube root of x plus 4. That little 3 right there, that's called an index. Remember that from your Algebra 2 days. But this is a cube root. It's still a radical. And I always want to isolate the heart of the equation. The heart of the equation is the radical part, so dividing by 3 is a good start. So now negative 9 equals a cube root of x plus 4. What's that you say? You don't know if this negative sign is going to be good? Well, let's cube both sides. Let's cube both sides. That'll cancel nicely with the radical. Negative 9 cubed. Negative 9 times negative 9 times negative 9 is negative 729, equaling x plus 4. So if I do a little subtract 4, we don't really need to show that, do we? We get negative 733. Or do we? Or do we means that you need to check the answer. Now, when you check the answer, you want to plug it back into the original problem. Oops, the original problem is the one with the negative 27. As I plug that back in, I am aware that I have a negative sign under here. Actually, it's going to be, I'm kind of running out of space writing this, so I'm just going to write the one side of the check. So now it's going to be the cube root of negative 729. Now, the cube root of negative 729, there is a cube root button in your math menu, or maybe you just realized that we're working backwards from what we did, and that's why it's going to come out to be negative 9. And 3 times negative 9? Oh, it is equal to negative 27. So it looks like I can do the cube root of a negative number and end up with an answer that makes sense. Now, the truth is, when it comes to certain radicals, certain even radicals, I should be circling actually the even index right here. Even radicals can never equal a negative number. Even radicals can never equal, whoops, not plus, I didn't want a plus or minus there, just a negative number. Can't happen. Odd radicals, like a radical of 3, or maybe I should be circling it right here, can equal a negative number. Odd radicals can equal a negative. Might have made sense if I had written even cannot. Now, I'm not big on memorizing rules like that, little details like that, but it is something that's true. But you're also going to want to check your answers. Okay, really, today's lesson and many of the lessons on to the end of the chapter, checking your answers is actually part of the process. Should we try another problem? Here's a radical equation, and the radical is not isolated. Nope, the square root of x plus 7, yeah, let's get these other numbers to the other side. You always want to isolate the radical. So I move negative x and I move negative 1, so I get x plus 1. Now we're going to square both sides, and we're going to do it correctly. Yes, that's right. We're going to square a binomial right here. We're going to square a binomial. This is the easy part. This cancels out to just be x plus 7. But x plus 1 squared, that's x squared plus 2x plus 1. Now remember, that's because I actually took x plus 1 times x plus 1, even though I didn't show it. Well, what kind of equation have we made now? That's right, it's a polynomial equation. Polynomial equations like to equal 0. So why don't you make it equal 0? Subtract x and subtract 7. Yeah, it's kind of an equation from last week. And it's an easy one. You can factor it. You can factor it. Two numbers that work out, x plus 3, x minus 2. Now remember, your solutions are still to be found, negative 3 and positive 2. Or are they? Yes, you have to check your solutions. You have to check them back in the original problem. I'm going to show this, okay, because actually this is kind of the part of the lesson that kids have most trouble with. So I'm plugging negative 3 back into the original problem. I'm plugging in two places, and I'm checking to see if it equals 0. So I get the square root of 4 plus 3 minus 1. That's 2 plus 3 minus, wait a minute, 2 plus 3 minus 1, that's 4. Now this kind of sometimes makes you wonder, did you make a mistake, or is 3 just really extraneous? It's extraneous. It's not a solution. It doesn't work. What happens if we plug 2 back in? What happens if we plug 2 back in? I got some new numbers here. What do we got? 2 plus 7, that is the square root of 2 plus 7. I'm also going to plug 2 right there. So that's going to be the square root of 9. It's actually going to be minus 2. I should just kind of rewrote the problem. But basically we're plugging in 2. We get the square root of 9, which is 3. I still have my minus 2, my minus 1. And, oh yeah, that does equal 0. That's because 2 is the only solution. Okay, so we're checking for extraneous solutions. It's just what happens when you have radical equations. Welcome aboard. Here's a radical equation. It's got 2 radicals. How am I going to isolate the square root? Well, I'm not going to isolate both of them. It's impossible. But I am going to isolate one of them at a time. Now, before I go any further, I should mention, don't you dare do this. This is a spin-off of a math teacher's nightmare. Don't square everything and think that you just got yourself an easy equation. You're not allowed to sort of, quote, distribute a square root sign. Instead, you have to isolate the radical. And I'm talking about just picking one of the radicals, basically making it by itself. Now, I can square this side and cancel, but when I square the right side, it has to be squared like a binomial. So again, the left side, when you square it, you just get 2x plus 3. The right side, maybe I better kind of think this through a little bit. I'm going to take 3 times 3 and get 9. I'm going to take 3 times the negative square root and get negative 3 square roots. I'm going to take the negative square root times 3 and get another negative 3 square root. And finally, I'm going to take negative square root times negative square root. Now, first off, that's going to be a positive. Next, you can either say that the square roots cancel and you just get 2x, or some students would say that you get the square root of 4x squared, but that's still 2x. All right, so we very carefully squared both sides. Now, after I do that, I've got some numbers that I can sort of combine. Namely, these numbers in the middle are negative 6 square roots. And I kind of survey the situation and realize that there's still a radical. Okay, I need to start over. I need to isolate that radical. The good news is the 2x's, they just happen to be the same. And I can subtract 9, kind of take care of that. Gives you negative 6 equaling negative 6 square roots. Of course, you're going to divide away the negative 6's. If you divide those away, you get 1 equaling a square root. And finally, I'm isolated, which means I'm ready to square both sides. After you square both sides and do a little math, you get 1/2. Or do you? Oh my, after all that work? Well, it does check. It does check. I'm not going to go through checking it, but you would plug it back into the original problem, and it's actually not that hard to do. You'll see that it equals 3. Radical equations. Isolate the radical, check your solution. Might work, might not work. Guess what? We're going to do another kind of equation today. Yep, we actually do 2 types of equations. Absolute value. Oh my, absolute value. Remember these from Algebra 1? Well, these are more college algebra absolute value because of all the x's. Now, what we want to remember is that an absolute value equation always gets split up. It always gets split up into a positive and a negative version. Let's actually kind of put that down as a talking point. Absolute value equations. Remember, the absolute value piece is going to always split to be a positive and a negative. In other words, it'll split to be the same and the opposite of the expression. Make sure that you're changing the correct expression. You want to always change what it's equal to. Okay, you always want to change what it's equal to. So we get version number 1. Version number 1 is actually equal to the same thing. We get version number 2. Notice that x squared minus 3x hasn't changed, right? I didn't change that, but it is going to equal the opposite. It's going to equal the opposite of the expression. Well, it's not an absolute value equation anymore. Yeah, I know, it's actually a polynomial equation. More specifically, a quadratic equation. I thought we were done with those. Nope, we're not done. That's actually why we studied them first, because now you just solve your quadratic equation, make it equal 0, right? Move some x's around, make it equal 0, and factor, factor, factor. If we were in class, you would be solving this on your own, so feel free to jump ahead of me. Okay, there's nothing too amazing about what I'm doing here. We're just kind of going through the quadratic type steps. But you do want to realize that when you solve the second side of this, when you kind of do the other version and you make it equal 0, you don't get the same equation. You get a negative 7x for one thing, and then you get a positive 6. Can that be factored? I think so. If you use an x minus 6 and an x minus 1. Now, what I supposedly have here are 4 answers. Wow, guess what? You have to check these 4 answers. Yeah, this is actually kind of the part of the problem that gives people the most trouble, just checking these numbers. And you have to check them back in the original equation. So let's try plugging in negative 3. Back into the original equation. Very carefully, I'm replacing each x with a negative 3. Now, you want to do like an order of operations. The order of operations would say that you work on the inside of the absolute value first. Once I'm on the inside, I see that I have an exponent that I can do. Careful, that's negative 3 squared. Those parentheses would probably be a good idea. So we get the absolute value of 9 plus 9. So I'm working on the inside of the parentheses. I can also mess around over here. And I think at some point I realized that I get 18 equaling 18. Actually, it's the absolute value of 18 equaling 18. So negative 3 makes the cut. Negative 3 is a solution. What happens if you plug in 2? What happens if you plug in 2? I got to erase all this because it's going to change, right? Now, you work on the inside of the absolute value, you get 4 minus 6. Over here, I can do what I need to do whenever I want to do. But it's this absolute value of 4 minus 6. Please make sure that you do the absolute value. Yeah, the absolute value of negative 2 is 2. Yeah, it's positive 2. I'm pretty sure that doesn't equal negative 8 plus 6. That's because 2 is not a solution. It's extraneous. I can cross it off, I can write extraneous, I can do both. Now, it would be in your best interest to try to plug in 6 and try to plug in 1. Again, you should try this. Do you want me to tell you what happens? Well, I'm going to, so you might want to pause the video. So try to check 6, try to check 1. And when you check 6, it doesn't work. It doesn't work because you actually end up with a positive equaling a negative. So that's extraneous. But 1 does work. Okay, I'm not sure why I'm circling everything. I probably should only be circling the ones that I want to work. Maybe I'll just cross off the ones that don't work. So the final answers are -3 and 1. Now, today we did radical equations and absolute value equations. Both types of equations I know you've messed around with. What you want to do is you want to clean up any of the loose edges. And now, a great way to do that is by doing these 2 exit problems. Now listen, every equation, as I mentioned, is going to have an exit problem. So we did 2 equations today. We got 2 exit problems. Just do these on your own paper. You can grab a half sheet of paper. You can use your own notebook paper. If we were in the classroom together, it's something you would probably turn in before you leave. There'd be some talking, which is fine. So have at it.